Okay everyone, this is going to be a screencast video tutorial for Learning Target 5.4, identifying different forces. We have 8 different forces that we have to be able to identify within a particular scene. What forces are acting on the object, whether it's moving or non-moving. Here are the forces. Number 1, we have static friction, which opposes the motion of a non-moving object. Very important there. Number 2, sliding friction opposes the motion of a solid object sliding over a solid surface. Number 3, fluid friction opposes the motion of an object moving through a fluid, in this case a liquid or a gas. And number 4, the last friction force opposes the motion of an object rolling over a solid surface. The key is rolling. And then we have gravity, number 5, very easy one here, force pulling objects toward each other. And in most cases we show gravity as a downward arrow because we're being pulled towards large objects like the earth. And buoyant force is number 6. This is an upward force acting on an object in a fluid, which again is a liquid or a gas. And then compression force and tension are both elastic forces. Compression is when something is compressed or pushed or squeezed together. It creates a force that opposes that. And then tension is the opposite. It is created when something is pulled or stretched, and again the force goes the opposite direction of the pull or the stretch. So let's see. Go ahead and erase these. We are going to go ahead and start with a diagram, and in this case we have a family riding a jet ski. It looks like the jet ski is moving. The first one I'm going to do is I'm just going to go ahead and draw in gravity. Because it's a force pulling objects toward each other, this object would move towards the earth. So gravity is going to be moving in that direction. So I'll put a G there for gravity. Number 1, gravity. I also see the object moving, so for something to be in motion, I know that a force must be applied. Let's say that the engine is applying a force in this direction, moving the object. I also know that anytime there's motion, there must be a frictional force opposing the motion. I have 4 friction forces to choose from. This object is already in motion, so static friction is not going to work. Sliding friction opposes the motion on a solid object on a solid surface. This is not a solid surface, this is a liquid. Fluid friction opposes the motion of an object moving through a fluid, liquid or gas. So there it looks like we found it right there with fluid friction. So number 3, fluid friction opposes motion, so it will go the opposite direction of motion, and that's going to be fluid friction. And that's number 3. And then I have to ask myself, is there any others? So I'm going to run through them really quick. I don't see any rolling friction. I already did gravity, buoyant force, and upward force on an object in a fluid. Now that one looks like upward force on an object in a fluid, a liquid or gas. So this object is in a liquid, so there's an upward force on an object in a fluid. We're going to call that number 4, and that's the buoyant force. Compression, a force that is created in the opposite direction of a push or a squeeze. I don't see one that's readily apparent in the picture, and same thing with tension. So I think we'll just go with gravity, engine, fluid friction, and buoyant force. Let's go ahead and try another one. If we take a look at this car driving down the street, we're going to go through the same exact list. First, what's the force being applied by the car? Again, it's the engine. And what direction is that motion? It's this direction. What's the next force? Well, if there's motion, there's got to be something trying to stop motion, and that's friction. So static friction opposes the motion of non-moving objects. Nope. Sliding. Motion of solid objects sliding over solid surface. Nope. Fluid friction. Moving through a fluid. Moving through a fluid. It says gas. So is the car moving through gas? I would say yes. So let's say number 2 is fluid friction. And fluid friction is going to be in the opposite direction of motion. And then let's look at rolling friction. Opposes the motion of an object rolling over a solid surface. So if the street is solid and the wheels are rolling, I guess rolling friction as well. So there's 2 types of friction. Acting on this object. And that will go in the same direction as the fluid friction, opposing the motion of the object. Let's see. Next we have gravity, always there. So I'll go ahead and put a gravitational arrow there, and that will be number 4. And buoyant force, oh no. Compression, is anything being compressed? I think we could argue that the tires are being compressed. We're going to skip that one. Tension, I don't see anything being stretched or pulled, so we're just going to stick with these 4. Engine, applying force to the west. Fluid friction and rolling friction, opposing that motion to the east. And gravity, pulling straight down. Okay, so that's the car driving down the street. Let's try another one. How about hitting a golf ball at the point, here's important, point of contact. So, number 1, there's definitely a force applied by the golf club. So I'm going to say the golf club, and that's this direction here. And that's going to be number 1. And as that comes through and hits the golf ball, it seems to me that as that takes place, the golf ball is not moving initially. So static friction is going to oppose the motion of this object. I don't think the arrow would be that big. Make it a little smaller. Number 2, static friction would oppose the motion of the golf ball. And if we go through the other frictions, sliding doesn't work. We could say fluid friction because it's moving through the air. So fluid friction. So as soon as the golf ball starts moving, there's going to be a fluid friction as well. And no rolling friction. So we've got static and fluid. And gravity. Yep, gravity exists. Let's put it as an arrow up here this time. So number 4, gravity. And buoyant force? No. Compression. Interesting. Is this golf ball being squeezed? I think so. It does appear as though it's not an exact circle. So it looks like the golf ball is being squeezed this direction by the golf club, which we already showed. The golf club's force is number 1. So the compression force pushing against this number 1 force here would have to go this way in the golf ball, pushing back against that force. And that would be number 5, compression force. Oops. And is there anything being stretched? I don't think so. So let's just stick with these. Golf club applying a force right. Static friction applying a force left. Fluid friction applying a force left to oppose motion. Gravity applying a force down. And compression force applying a force within the golf ball to the face of the club left. Okay, let's try one more to wrap up all of these options together. So, number 1, is there a force being applied by something in the diagram? It's a chicken pulling a cart, so it looks like the chicken is moving this direction. So let's say that they're applying a force in that direction. So I'm going to say the chicken pulling is definitely the first force in this picture. So then I'm going to look on all these forces that I've learned and ask myself, is there any of them? Well, let's see, static friction opposes motion of non-moving object. I don't think so. Sliding friction, this is sliding over a surface, not that either. Fluid friction, is the chicken in the cart moving through a fluid? I would say yes, because a gas counts as a fluid. So we would have a fluid friction going the opposite direction of motion. So number 2, fluid friction. And then rolling friction, is there anything rolling? Yes, there is. There's the little wheels on the cart there. So rolling friction also opposes motion, so that's number 3. Rolling friction. And gravity, oh yes, gravity is definitely going to be acting on everything on the surface of the earth. So gravity will be number 4. And buoyancy, no, because it's a solid surface, it's not a fluid, so no buoyancy. Compression, is anything being compressed? I don't know that I see anything being squeezed, so let's cross that off. Tension, force that's created when opposite direction. Pull or stretch, I do see the chicken pulling, so I wonder if there's a tension force in the string there, or the rope. So let's say that if the chicken is pulling this direction on the rope, that the rope is pulling back with a tension force, the opposite direction of this number 1 pull or stretch. So number 5 will be tension force. And the tension force is the opposite direction of the stretch or the pull. Okay, there you go. We have gone through 4 examples and covered all the 8 different types of forces that you will be responsible for identifying. Good luck, and if you have any other questions, see your instructor.